Oh. All right, so lately I have been building a custom lighting system for my band's shows, so let's dig into it a little bit. It all began when I was frustrated trying to reliably control some WLED strips in my room. So I thought, let's build a little Rust server that holds open WebSocket connections to the boards. Then I pull up a little UI. If I see a green little connection light, that means anything I do is going to reliably work. And it did. Come home, pull it up, turn them on, they turned on instantly. It was... Now, as a band, we use Loopy Pro for our backing tracks, guides, and clicks. It's a bit unorthodox for a band, but I use it in my acoustic sets, and it works, and I'm just going to make do with kind of what I've got. One night in Loopy Pro, I realized they have an OSC protocol, which means you can remotely play and stop tracks remotely over the network. And that's when the lightning bulb hit, basically. I was like, I can use my lighting server to send off a lighting command to these lights. At the same time, I can hit play on Loopy Pro. So then all I needed to do was build up a UI with the waveform. So I'd drag my songs on, I'd see the waveform, I'd click cue markers along the waveform, say I want strobe here, I want this here, I want that here. Then I'd hit play, it would send the message to Loopy Pro to hit play, and it would start a program for these lights. The tubes themselves consist of just, I bought this aluminium tube off Amazon, ran a 1 meter LED strip inside it. Then we have the bomb that hangs off the bottom at the moment. This is a charge circuit, 2 batteries in it, and then a ESP32 with WLED running on it. So that's Wi-Fi controlled, and a little switch just to like, back on. So let's get into the nerdy side of it. The heart of it is basically a Rust server running on a GLI travel router, which also has a Svelte front end, which lets me control it from the tablet and set up the programs. When I hit play, the Rust server sends out 40 UDP packets per second per board over the Wi-Fi to WLED ESP32 chips. When I first had it set up, I was using the effects on the WLED chips, and that was fine. The presets would change in time, but the presets weren't in time themselves, like they wouldn't flash and pulse with the BPM of the song, and of course I wanted that. So we made a custom effects engine, so now we're bypassing the effects on the WLED chips themselves. We're sending direct per LED UDP messages to the boards. I had to recreate a lot of the effects on WLED plus some of my own, and they're completely in sync with the music, like they'll pulse in time. Now at that point, all of the tubes were doing the exact same thing. If you played one effect, they mirrored each other basically, and of course that wasn't enough. I wanted effects where, I don't know, things would happen across the tubes, or you get like a Mexican wave, or we could have center in and wipe out and stuff like that. So then I had to build a pattern engine on top of that FX engine, and now they are all in their own DMX universe rather than being in one universe. Now let's talk about the elephant in the room, AI, of course. I managed to finish this project in a matter of months. Without AI, it would have taken so much, a year. I'm a software developer by day, so at least I have some idea of what I'm doing. But just going through with the AI, finding every bottleneck, every inefficiency possible. The first time I had them strobing, it would strobe about 3 times, and it would cut out and then keep strobing. And I was like, no, where's the bottleneck? And getting the AI just to brutally comb over. Surprisingly, on the travel router, we are not hitting the CPU at all. The CPU tickles at about 4%. It's doing nothing there. And as I kept ironing out the inefficiencies in the Rust code, it's performing pretty well. We played it out last weekend, and I was concerned that, Wi-Fi signals in the bar and everyone's phone would kind of disrupt the UDP packets. But there was little glitches now and then, but overall I would say it was pretty damn reliable. So let's get into a little bit about how you actually use it. On this front page, you've got your boards. You can add a new board with the IP address. Then the fun begins when we come into the programming page. Here, you can pull up any WAV file or MP3, drag it in, wait for it to encode. Once the song is loaded, you'll get a program, your little UI with the waveform and everything. And now in here, we can right click, New preset. I can make a preset. Let's go. All right, Pulse Cyan, my favorite colors. Hit save. Come back out. Let's go before the little drop thing. Burst screen and then Pulse Cyan. Bum, bum. And that's totally in time, which is awesome. I also added in sync rates to it. So right now that was pulsing on every 1 beat. We could make it pulse on every 2 beats. If I come back and hit play again. Bum, 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 bum. Yeah. We also have, lightning, strobe, wave reverse, wipe up. Let's do wipe up. Wipe up's pretty cool. Bum, bum, bum. Whoa. Double speed. Let's try half with that. Ah, that's cool. And then when you're done with programming, we can come across to the performance page. This is what my drummer sees on the iPad next to him, and he can simply just click one of these. I also added an ability to chain programs, so you can make one program play after another. And yeah, we tried it out last weekend with all 6 tubes running, and it worked pretty damn well. And instead of having bombs hanging from the tubes, basically, I've had this 3D design printed, which has the batteries and the WLED chips inside, all nicely soldered up, which fits on the back of the groove like really well. For future considerations, I'm tempted to and slightly have started actually building an audio playback engine next to the lighting server. Right now with Loopy Pro for the backing tracks, Loopy Pro is great, but having it running on an iPad, we have to have a USB connection from the iPad to our mixer. iPad OS treats USBs as accessories. If you have fully charged your iPad and you have the charger in, it will disconnect the power, disconnect the backing tracks and everything. I can't have that. So hopefully in the future, I will have just a little Nook PC running in our in-ear monitoring rack that'll control the lights. It'll have a USB connection straight to our mix. It'll be running Linux. The audio engine will be running in a thread with the highest priority. It won't get kicked off. And we will have a backing track, click, lighting server all in one. This whole project is open source, of course it is. It is up on GitHub at the moment. So if anyone wants to join in, if there are other bands out there that want this as well, get in touch. If you're a software developer who wants to help out, amazing, great. I thought it was just a really good way for kind of small bands to have their own lighting and not have a dedicated lighting guy because they can't afford it because they're a small band. So this gives bands a way to be able to give a sick show at a small gig.